This is an introduction to dimensional analysis, also called the factor label method. We're starting off with colors here, so if you happen to be colorblind, you may want to skip ahead to the mathematical problems. But the colored items help you see how the process works. Let's say our problem is to convert 14 black beads to pink fuzzies. So you always start off with what you are given. In this case, we are given black beads and we are given 14 of them. So we're going to start with that, 14 black beads. Now we want to cancel black beads. So our conversion factor is going to have, this is multiplication, it's going to have black beads on the bottom. And our choices are to go from black beads to orange, but then we're sort of stuck because there's no other oranges. Or we can go black beads to yellow. And our conversion factor for that is 1 to 1. So 1 black bead is equivalent to 1 yellow fuzzy. So black beads cancels. And right now we're left with yellow fuzzies. So our next conversion factor, we're still trying to get to pink. So our next conversion factor, we're going to go from yellow to purple. Since we have yellow on top here, we want it to cancel. So the yellow automatically goes to the bottom. And the only two conversion factors we have with yellow are yellow to black. Well, we don't want to go back to black. We were already there. That's where we started. So that would be going backwards. So we want to go from yellow to purple. Our conversion factor for that says 2 yellows are equivalent to 3 purples. So 2 yellows are equivalent to 3 purples. Now our yellow fuzzies will cancel. And now we want to cancel purple fuzzies. Remember, we're trying to get to pink. Our purple fuzzy needs to go on the bottom so that it will cancel. And we're trying to get to pink. I don't have any more of the small pink. So when we go up here, we see that a purple and a pink conversion factor, 1 purple is equivalent to 3 pink. So 1 purple is equivalent to 3 pink. So our black cancels with our black. Our yellow cancels with our yellow. Our purple cancels with our purple. And we're just left with pink, which is what we're trying to find. So to work the math, we multiply across the top. So we have 14 times 1 times 3 times 3 pink fuzzies. On the bottom, remember this is over 1, so it's 1 times 2 times 1. So on top, we have 14 times 3 times 3 on the top, which is 126. On the bottom, we have 1 times 2 times 1, which is 2 pink fuzzies. So we end up with 63 pink fuzzies. So 14 black beads is equal to 63 pink fuzzies. So hopefully you saw whatever unit is here in your given needs to go here in your conversion factors so that they cancel. And whatever unit ends up here goes down here. So these always match. These match, these match, these match. And whatever you're left with at the end is what your final result will be. If this didn't make much sense, then hang with me. We're about to do this with numbers. The way that we work this out is we start with whatever we're given. So in this problem, we are given 3.52 moles. So we start with 3.52 moles, and that's over 1, which of course you don't have to show. So our conversion factor always has whatever this unit is on the bottom, so that this unit will cancel with that unit. And what we're trying to get to on top, we're trying to find atoms, so atoms will go on top. And 1 mole of anything is 6.022 times 10 to the 23rd. So the mole unit will cancel, and that's the whole idea of dimensional analysis or factor label, that whatever unit you have cancels and you go to this new unit, which is atoms. Sorry, I forgot to put that in there. So my calculator seems to have disappeared, so I'm going to have to use this solar one. So 3.52 times 6.022 is 21.197 times 10 to the 23rd, because we got to not forget this part. So I multiply these two numbers, and then I have that part. Now this is not in scientific notation, so I'm going to have to move that decimal over 1 place. So it's going to be 2.1197 times 10 to the 24th, because I moved it over 1. And then if the number gets smaller, the exponent gets bigger to compensate. If we had moved it the other way and made the number bigger, then we would have made the exponent smaller. And then we go back and we look at how many digits our original problem had. It had 1, 2, 3. So we're going to keep 1, 2, 3. We're going to cut this number off here. So we are left with 2.12, because if this is 5 or more, we round that last digit we're keeping up, times 10 to the 24 atoms as our final answer. Let's do one that takes several steps. You could probably do this problem without using the factor label method, but we're going to use it to show the method. So we have 4.25 days. I'm going to use D for days. And then we want to convert that to seconds. I don't know how many seconds are in a day. So I'm going to put 1 day down here, and I know that 1 day is 24 hours. Well, my days cancel, but now I have hours. So I want to cancel hours. Hours is on top, so I automatically go down here. I put my hours, and I know that 1 hour is 60 minutes. Well, I'm not asked for minutes. I'm asked for seconds. So my hours cancels, and now I'm left with minutes. So if I solved it now, I would have minutes. But I want seconds, so I need to go another step. I want to cancel minutes, so 1 minute is 60 seconds. And then to solve this, my minutes cancel. I have seconds on top. To solve this, I'm going to take 4.25 times 24 times 60 times 60. So we multiply across the top. We multiply across the bottom, but that's 1 times 1 times 1, so we get to ignore that. And I get 367,200 seconds. Because that's the only unit that's left. All the other units canceled. So you're always going to see this pattern with whatever you're given goes on the bottom, whatever ended up on top goes on the bottom, whatever's on top goes on the bottom, so that the very last upper right hand corner is what you're trying to find. Let's do a problem with stoichiometry. So first we need a balanced chemical equation. So let's use H2 plus O2 yields water. And we need to balance this. We have 1 O here, 2 O's there. So I'm going to have to put a 2 in front of this. That gives me 4 H's. I have 2, so I need to put a 2 in front of that to get 4 H's. So that's now balanced. With a stoichiometry problem like this, we can also use the factor label method to solve it. Stoichiometry means that you need a balanced chemical equation because you need the coefficients. Remember, if there isn't one, you assume it's a 1. You need the coefficients to solve the problem. So the first step is always to take whatever you're given to moles. If it's already moles, you get to skip the first step. So we're given 320 grams of O2. We want to get this to moles. So our conversion factor, we have to cancel grams of O2 and go to moles of O2. And 1 mole of anything, you can figure out the mass from the periodic table. So we look at the periodic table, and the mass of 1 oxygen is 16.00 grams per mole. Well, we have 2 oxygens, so we have to double that. So 32.00 grams per mole. So we have 320 divided by 32, which is 10. Our grams of O2 cancels, and we now have moles of O2. But we aren't asked about moles of O2, we're asked how many grams of water. So our next step is to go from oxygen to water. So this is called the mole ratio step. But we're still just going to use the factor label method or dimensional analysis. So we start with our answer to this last one, which was 10 moles of O2. And we're going to multiply that. We want moles of O2 on the bottom so that the unit cancels. And we're trying to find moles. We're trying to find out about water. So we want moles of water on top. So mole ratio means you need to have mole over mole, and the number that goes in front comes from the balanced equation. So if we look at our H2O, we go up to our balanced equation, there's a 2 in front of it. So that 2 goes in front of my H2O. And I go up here in front of oxygen, there's nothing, but remember that means that there's 1 mole of oxygen. So we're going to do 10 times 2 divided by 1. This unit cancels, and we're going to be left with moles of water. So now we have 20 moles of H2O. But we aren't asked for moles. We're asked for grams of water. So we're going to do another conversion. And our third step is to get our moles to whatever's asked for. It might be volume, it might be grams, or it might be moles, and we would be done. So the third step you need if you're not asked for moles at the end. We're asked for grams, so we need it. Again, we take our starting point was our ending point of the last one, 20 moles of water. Our conversion factor, we need moles of water on the bottom. And 1 mole of anything, we can figure out the mass by adding it up off the periodic table. So hydrogen is 1.01, we have 2 of those. So that's 2.02 plus our oxygen, which is 16, which gives us 18.02 grams of water. So notice on both the first and last step, when you're going between grams and moles, the moles is always going to be 1, and the grams you add up off the periodic table. The middle step, which is always required, you always have a mole step in these stoichiometry problems. In this one, we're going to have mole over mole, two different things. And so here we use the coefficients. This is the only place we use them. We do not use them to find mass. We do not use them in the first or last step. We only use them in our mole ratio step. So let's finish this off. We have 20 times 18.02, which is 360.4 grams of water. We go back and look at our original problem. We were given a number that had two significant figures, so we're going to keep two significant figures. So our answer is going to be 360 grams of water. If you need more help with the stoichiometry, I will do a separate video on that. I just wanted to show you how you can use dimensional analysis in solving these more complicated problems. Have a great day. Come back and see me again.